So remember, it's important that as you look at this whole diagram, you appreciate that we're looking at one VPC. We're not looking at one VPC on the left, one VPC on the right. Remember, even though we've got things distributed across these different physical locations, availability zones, we've got one VPC. The VPC construct is logical, and this is one network we're looking at. We're just looking at all these lines are just the parts of our network communicating with each other. Some obvious points, you'll notice that if you can see 0000/0 as the destination in the route table, then you've got a catch-all route. And if it's got the internet gateway as the target as well, you've got the criteria met for making that subnet a public subnet. So because this is all zeros and I can see internet gateway as the target, IGW, I know this is a public subnet without even looking. If I look at this route table, because I can't see all zeros and internet gateway, I know this is not a public subnet, it's a private subnet. And if I look at this route table, I can just see this is a private subnet. We do have the local route. We've got 10.0.0.0/16, and then the target is this endpoint ID. And remember, 10.0.0.0/16 is the VPC seeder. So we do have the local route, but that's nothing to do with whether the subnet is public or private. Just because we've got a local route, or rather, let me be more precise, just because I've got the VPC seeder as the destination, that doesn't make it a public subnet. That just means things can move about within the subnet. And that's another point. This is the VPC seeder 10.0.0.0/16. But we don't have the word local. This is a specific VPC ID. So just because we've got the VPC seeder here, don't assume, because your intuitions will make or break a fault. So don't assume that just because on the left you've seen VPC seeder, you're looking at a local route. Well, it doesn't say local on the right here, does it? It kind of is a local route because we're giving our own address, but it's a precise local route at least. It's precise. We're giving a VPC ID for availability zone B here. And that's so that this database here in this private subnet can communicate with what? Well, some sort of endpoint in this availability zone. Another thing to point out with this diagram is this firewall subnet, because it's a subnet, it does have its own seeder block. It's 10.0.30.0/20. Remember, that's how we separate out numbers within numbers when it comes to this dot notation. So the overall thing is seeder range is 10.0.0.0. So if we want a subnet within it, it becomes 10.0.30.0. So we increment one of the octets to be a number. So it becomes 10.0.30.0. And it's also become /28 rather than /16. So that's the firewall subnet. Well, we don't actually name the firewall subnet in our ALB route table, do we? We don't say, there's no rule here that says 10.0.30.0. So we don't actually direct traffic, even though the traffic does go from the ALB to the firewall endpoint. We don't achieve that by having a rule which names 10.0.30, the seeder range for the firewall subnet. All we have is a catch-all route going to the internet gateway with the target as the internet gateway and this VPC seeder with the endpoint ID for availability zone A. So it's quite indirect the way it works. I think it's quite counterintuitive. But all we put is 10.0.0/16, and then the target is an endpoint ID specified to this availability zone. Now that means that we're not going to be able to use this firewall endpoint, and that's a good thing. So even if we mistakenly thought, oh, let's go and filter the traffic over here in AZB, well, we couldn't. And so because all we do, we only have the root, we only have instructions for 10.0.0.0 /16 with an endpoint of AZA, and this is a key part. It is specifically the endpoint for availability zone A, so it is limited. We only have the instructions for the endpoint in availability zone A. Of course, there's no way to use a CEDAR block to specify an availability zone, but if you combine the CEDAR block with the target, then you can get that specificity. The diagram doesn't show this application in the private subnet in availability zone A doing anything, but it can do things. We know that it can because it's got the local root with the availability zone A endpoint, and it does have 10.0.10.0 /24, and then the endpoint ID for availability zone B. Now you see that is a specific CEDAR, 10.0.10.0 /24. So this is going to the public subnet in availability zone B. So that is precise. We're not just saying you can have a local route, we're saying go over here. And that's an important difference between this subnet at the top here and this private subnet in the middle here. When we want this public subnet to be able to communicate with the firewall endpoint, we give it a broad CEDAR range. We only give it 10.0.0.0.16, which is the whole VPC, right? That's everything in the whole diagram, including AZA and AZB. Again, the target, though, is only for availability zone A, but still, we give it the CEDAR for the whole VPC. But when we want to give this private subnet for the application, when we want to give this instructions for communicating, we give it a specific CEDAR. And that's a real asymmetry, I think, because both of the destinations are in subnets. I mean, the firewall subnet here, which we want the ALB to send things to, that's in a CEDAR. I mean, we could have put 10.0.30.0 /28 in the root table, and we don't. Where's 10.0.30.0.28? It's not in the root table for this public subnet with the ALB in, is it? And yet, we are sending it to this firewall subnet with 10.0.30.0.28. And yet, when we come to this private subnet with the application in, and we want it to send things to the ALB in AZB, we do provide a specific CEDAR. We do scope down the CEDAR, and we provide 10.0.10.0 /24. So there's a difference in how we approach things between giving the directions to the public subnet and giving directions to the private subnet. How might we explain that? There must be a reason. We give a general CEDAR range in one case and a specific CEDAR range in the other case. Why? I mean, one explanation is that it matters that the application sends its traffic to this specific subnet, and it's more important that precision is here than precision is with this public subnet. We actually only care so much about the public subnet. In other words, all we need to do is provide the CEDAR the CEDAR of the VPC. That is sufficient. Providing the CEDAR of the generic VPC with an endpoint target, but it's we need to provide more precision when it comes to the middle application layer communicating with the web layer. We need to then say, okay, you need to have this actual seeder block of the subnet as your destination, 10.0.10.0.24, for this application layer to go up to the web layer, the ALB over here. Maybe the thought is we could provide a specific subnet as the destination over here. It's just that we don't have to. Maybe that's the way that it works. Consider the route table for the public subnet on the left. One entry has the VPC seeder for the destination, but it does not have local written as the target. Instead, it is the endpoint. Even though we can do this, we don't always want to. The above image shows an ALB which wants to initiate communication with an app tier in the same VPC. Sometimes, we still want to be putting the endpoint next to the destination of all zeros. Yes, but we do not see that. Every rule which is all zeros in this diagram has an internet gateway next to it. But maybe it's the case that we can put an endpoint target next to the destination of all zeros. When should I put the endpoint target next to all zeros, rather than the VPC seeder? Let me read that again. When should I put the endpoint target next to the destination of all zeros, rather than the VPC seeder destination? Well, if you want to intercept traffic heading outwards towards the internet, put the endpoint next to the all zeros destination. In the image above, we want to intercept traffic as it passes from the top tier to the middle tier. This is an internal movement which is not aimed at the internet. Therefore, we put the endpoint as the target for the VPC seeder. In other words, we have a route which is 10.0.0.0/16, and we've got this endpoint ID for that availability zone as the target, because it's only going from the load balancer to the middle tier, to the app tier. In the image above, consider the route table for the private subnet in Availability Zone B. It is a best practice for the traffic to be inspected at the local firewall subnet in the same Availability Zone B. This seems to be achieved easily by simply replacing the word local with the endpoint for the AZ. Then we give a specific seeder as one entry. This is the seeder of the subnet in the other AZ. However, in terms of targets, we have two endpoints. Let's take a look. So this is Availability Zone B. This blue background is a subnet in Availability Zone B. And it's got the VPC seeder, but it's also got 10.0.0.0/24. Notice the 24. And it's an endpoint, the target is an endpoint ID in the other availability zone, Availability Zone A. Okay, just observing. Now let's make some comments on that. Okay, so we've got two targets, they're both endpoints in this case. The above route table can be confusing. If the more specific route is given priority, /24 is more specific than /16, then surely we are not sending traffic to the firewall endpoint. The firewall endpoint is Availability Zone B. Look, you can see that AZB is with 16 and A is with 24. So surely we're not sending traffic to the firewall endpoint. The specific route is AZA, so we're not sending traffic to the firewall endpoint. This is indeed a troubling thought. So let's resolve that then. So we're talking about this route table here on the application layer, the middle layer. We've got two endpoint targets, and I've pointed out that it looks like the more specific route has the VPC endpoint ID for availability zone B, What can we say to resolve that? I mean, do you agree with that? Do you think that traffic will only go to the endpoint ID in availability zone A? Even though we're in availability zone B, the specific route is to availability zone A. Is that not a problem? Well, that does seem unusual. I mean, let's look at this database subnet. Here we've got a similar situation. We've got a 16 and a 24. And again, the /24 is the other availability zone. We've got /24 and availability zone B, even though we're in A. And because of the LPM principle, longest prefix match, the 24 should get priority. But maybe that's the point. We don't want the subnet to be doing things. You will only speak when you're spoken to. You're a database. We only want the application to come to the database and then the database to return an answer. We don't want the database to start going to the application and the application sending something back. Maybe that's it. And maybe that's what's going on with the middle tier here. We've said it's the specific route 24, it's high priority, and maybe that's the point. We actually want we want it to be the case that the 10.0.0.0.16 takes a backseat, which has a target of the VPC endpoint ID in availability zone B. But I'm not sure that works because we have got 1, 2 written in blue circles, meaning we want it to go first to the firewall endpoint in availability zone B, then to the database. And yet the 24 is straight away moving into availability zone A. So we'll have to come back to that issue. This is a summary of the firewalls then. So we have security groups, NACLs, WACLs, and network firewall, and then we got DNS firewall. So security groups we've had since 2006, probably. 2009 for NACLs, probably, when we got the VPC service. The WACL, the web application control layer, access control list rather, is in 2015, and then 2020 we got the network firewall and the DNS firewall in 2021. Can the firewall moonlight, meaning can we have one firewall that we kind of have guarding many things? For a security group, yes, you can have that security group associate with multiple EC2 instances or application load balancers. Can the NACL moonlight? No, it is local. It is loyal rather to one subnet, so the answer is no for that. What about the WACL, the Web Access Controllers? Can that moonlight? Well, its rule groups can be used in different WACLs. What about the network firewall? Can that moonlight? Yes, that can moonlight. We can have the protectee for the network firewall is a VPC, and we can have multiple VPCs protected by one network firewall. We've talked about the different deployment models. We have the centralized deployment model, and that's where we have multiple VPCs and they all send their traffic for inspection at one network firewall. So yes, it can moonlight. The DNS firewall, can that moonlight? Well, we'll have to come back to that. Can it be a team player? Meaning, can we have one protectee, one principal, guarded by multiple firewalls? Well, with security groups, yes, you can have them be part of a team. With NACLs, no. You have to commit to one NACL. Actually, I think NACLs can moonlight. You can have one NACL with many protectees, perhaps, but it certainly can't be a team player. Yeah. What about a WACL? Can that be a team player? Can we have multiple WACLs on one protectee? I would say, I'm pretty sure no. No, you've got to pick one WACL. Network firewall, yeah, that can be a team player. You can have one VPC with multiple network firewalls. It would just be complicated to set up. What about allow exclusivity? Well, we know that security groups have that. They exclusively make use of allow rules. But we don't see that in NACLs. We don't see that in WACLs. We don't see that in the network firewall. And I don't think we see that in the DNS firewall. Stateful rules? Well, in the security group, there's only stateful rules. In the NACL, no, none. What about the WACL? Are there stateful rules in a web access control list? Are there stateful rules in a network firewall? Yes, there certainly are. Stateless rules? Not with a security group. With a NACL, it's only stateless rules. It's like exclusively stateless rules. With a WACL, are there stateless rules with a WACL? We'll have to come back to the issue of statelessness with a WACL. There are stateless rules with a network firewall. Is it irksome? Does it have exhaustive rule coverage, meaning everything can be covered by rules? Not with a security group. Remember, you can have traffic which is controlled, but it's not attributable to any particular rule. NACLs are irksome. They have exhaustive rule coverage. WACLs are not. They're similar to security groups in that respect. Network firewall, is that irksome? I would say yes. What about concurrent coverage? Can we have concurrent coverage, meaning have traffic entities which are covered by multiple rules? Well, we can with a NACL, we know that. You can have the default deny, which covers everything, but it's not effective because you've got a blanket allow rule on top, which is more specific. Can we have concurrent coverage with a security group? Yes, you can. You can. You can have two allow rules where one is more specific than the other. And so you can have one item of traffic where you say, well, it's covered by both rules here. And I think the answer is that the broader rule actually gets applied, which is quite alarming. With a WACL, is there concurrent coverage? I think yes. With a network firewall, is there concurrent coverage? I think yes. Is there an implicit action? What is it? Well, with a security group, the implicit action is deny. With a NACL, you can configure the implicit action by making use of rules. And you can toggle the implicit action with a WACL using the default action radio button. And a network firewall, does that have an implicit action? We'll have to come back to that. IAM policies. So far, we've only talked about putting limits upon the network traffic which is allowed to pass into the ENI and the subnetwork. Another method of maintaining the security of your AWS resources is using IAM policies. IAM stands for Identity and Access Management, and it's an AWS service. It was part of a triad of services announced in 2010, along with Route 53 and the Simple Notification Service. IAM policies offer more fine-grained controls on access. There may be multiple resources on one EC2 instance, and so a security group could obviously not differentiate between one resource and the other. IAM policies are JSON documents consisting of key value pairs. You have a virtual playground, as it were, and you need to control who is allowed to play on what. IAM policies have a number of elements that you'll see repeatedly. They can be captured by the acronym EPARC. EPARC. Effect, Principle, Action, Resource, Condition. The acronym helps because, especially when new to AWS, it can be helpful to actually notice when one of the elements is not included. Sometimes a resource is not included, or principle, and it can help with learning the language of AWS to really notice those absences. The effect is either allow or deny. Notice the similarity to rules in NACL. The principle is the agent performing the action, which we want to control. The action is the API call being performed. The resource is whatever the action is being performed upon. Misconceptions over IAM policies. A substantial number of people have the following beliefs about IAM policies. If I distinguish a minority of individuals and deny their being able to do something, then everyone else will be allowed to do it. But that's a false belief. FB free. So if I distinguish a minority and deny them, everyone else will be allowed. Those who hold this belief think that using an IAM policy is akin to splitting a log into two pieces. All the principles in the world are split into exactly two groups, those explicitly allowed and those explicitly denied. If you explicitly put people in one group using your policy, the rest are shoved in the other, and thus the universe is exhaustively sorted into two groups. There's some evidence from forums that FB3 is a widespread belief. The belief is not entirely unreasonable. If we look at how NACLs behave, exhaustive rule coverage holds. Everything must be accounted for by some rule. AWS provide a default NACL, which comes with a blanket rule pre-installed that allows everything. I call it the apron allow. You're then going to set up the NACL to use as a deny list, pinpointing individuals to deny, against that background of a apron allow, which is pre-installed. Note, though, that that's not true of a NACL you create, but it is true of the default NACL. NACLs you create are different. Do we have an evaluation order for AWS IAM? I'm trying to find out one problem with IAM policy of one of my user. I have policy which says deny access if the service is not in our list. I'm trying to grant access to my user for all action of API gateway. I've provided the policy below, but it is denying access for all action other than get options head. It's denying actions for all actions other than get options head. I have the wildcard character in the beginning, which will individual actions override the wild character settings. I'm trying to understand the evaluation order for IAM. Does the individual action override the star? So we've got effect, deny, resource everything, star. So we're denying everything, denying all resources, but then we've not got an action we're denying, but a not action. So you have to think in your head. If this were action, we'd obviously be denying these specific actions: API gateway get, API gateway options, API gateway head. So you have to revert. So you've done that thought experiment, right? If it were just action, it would be that we'd be denying. But because it's not action, we're denying all the things that aren't these actions. So we're denying everything. We're explicitly denying everything apart from this subset of things where we're not saying anything about them. But this poster is suffering from red eye. FB3, false belief 3. He thinks that by pinpointing some actions and denying them, he creates a red eye against a green background. He thinks he creates an explicit deny surrounded by explicit allows. Remember, he's doing deny for all actions apart from these, so he thinks that he'll be left with these that are allowed. What this essentially means is that if you create a subnet, you are then given a firewall which allows most things. But generally, one action, creating a subnet, leads to a resource being created which allows most things. And people believe that denying a minority with an IAM policy is an action that's on a par with creating a subnet. In other words, the action results in the creation of a permissive barrier. And so false belief 3 isn't irrational, it's really rather reasonable. But there's something else that makes FB3 quite persistent. In explanations of how IAM policies work, it's common to hear something like this, which I'll call blanket deny. By default, all requests are implicitly denied with the exception of the AWS account root user, which has full access. Okay, by default, all requests are implicitly denied. And that wording's from the official documentation. Notice the similarity to the property possessed by security groups with their allow exclusivity. FB3 is so persistent because it's not clear exactly what default property they are overriding when they choose to create an IAM policy. The IAM policy could be adaptable in the manner that a NACL is. A NACL can be configured to be an allow list or deny list. And it's conceivable that IAM policies, which can allow or deny just like NACLs, also have this flexibility to shift between the two modes. We can interpret that blanket deny, by default, IAM policies implicitly deny. We can interpret that blanket deny as simply stating that one of these two modes is the default, such that by creating a policy that selectively denies, we thereby express our preference for the other mode. That is, we express our preference to exit the default, thus allowing the majority of users because we've selectively denied someone. We express our preference for the allow list mode to be activated. It seems to me, is a reasonable reading of blanket deny, which explains the persistence of FB3. So we might say that the problem with blanket deny is as follows. It employs that expression that's really troublesome and really annoys me, by default, and it attempts to explain what happens as a matter of course. That's what blanket deny is all about, right? By default, all requests are implicitly denied. It uses the expression by default and it attempts to explain what happens as a matter of course. However, actions which occur as a matter of course are usually contrasted with things you do. Through configuration, if it's something you do, default behavior can be overridden. And many view pinpoint denials using an IAM policy as configuration. It's configuration that overrides the default behavior described in BD. And this explains why repeating BD, blanket deny, actually isn't usually very effective. It's compatible with the widespread misconception about IAM policies. More generally, that adverb by default is ambiguous, and I think it should be avoided actually in most circumstances. It can either denote behaviours that are 1. Essential to the technology and non-configurable, or pre-configured but configurable. If it's intended to denote that first thing, the essence, right, by default meaning it's essential of the technology, if it's intended to denote essence but it's read as 2, configurable, then users think they've been oversold on the flexibility of the technology. If pre-configuration is intended but it's read as 1, then the technology is just underutilized. It's also ambiguous as an adjective. Often we're told about the default X, where X is some noun. Many people talk about the default rule in a NACL and about the default route in a route table. The default deny rule in NACLs is a catch-all route for anything that doesn't match rules which are more specific. This is similar to the way that the entry with all zeros in a route table will cover traffic for any destination not covered by a more specific route. And yet when people talk about the default route in the context of route tables, they're in fact referring to the entry with target as local. So sometimes default X means X which functions as a catch-all, and at other times it means X which is already in place. So we must be careful when we use the adverb by default and any compound nouns such as the default X. Are we talking about something that's innate, there from the beginning, or are we talking about something which is a catch-all in terms of the things it covers? False belief free contained the idea, which is informally red-eye, it contained the idea that if I deny a pinpointed minority from doing something, then I thereby allow everyone else to do it. If this is indeed false, it is, with IAM, then the question is raised over the point of denying particular individuals in an IAM policy. Given the blanket deny, properly interpreted, any deny policy now just seems like adding a spot of red paint to a red wall. IAM policies that deny achieve nothing. False belief 4. If blanket deny holds, then deny IAM policies are pointless. This belief is false, however. To understand why, and rescue the point of IAM policies, we can reintroduce a property we've seen before. We said that NACLs had this property of concurrent coverage. This was the fact that single packets can be covered by more than one rule. And recall that this does not result in paralysis because rules are uniquely numbered in NACLs and lower rules are lucky and given priority. Well, concurrent coverage holds with IAM policies as well. One consequence of this is that we can carve out the permissions we want. I use the expression carve out because when you carve a statue, one action builds upon the previous, and you're creating the desired result by removing material. With IAM policies, you could explicitly allow an island of users, perhaps a whole school. Then you could explicitly deny a subset of the allowed route. Perhaps Class 12 is on a ski trip, so they shouldn't have access to the school's photograph preview site. We first carve a section and the photographs are for people at the school, not people away on a school trip. We first carve a section out of our block to achieve the set of allowed users we desire. Class 12 is referred to by both the school allow policy and the distinct deny policy. And the deny policy is enacted because of this, which denies the ski trippers. The deny policy is enacted because of this principle, the dagger deny. If an entity is both allowed and denied by multiple IAM policies, then the deny will cut across all policies. We see this where the documentation states, remember, an explicit deny in any of these policies overrides the allow. And we can use the override principle to our advantage when we carve out the permissions for the whole school, except Class 12, to view the photograph platform. Anyhow, we've explained why FB4 is false. Deny statements are useful because they allow us to reduce the size of allowed entities in a precise manner. Blanket deny does not render deny statements useless.